Telomere length declines during aging, and that's what we can see here with data for men and women. On the y-axis, we've got LTL, or leukocyte telomere length, so telomere length in white blood cells, plotted against age on the x, within the age range of about 20 to 100 years old. And then we can see the age-related decline for telomere length, such that in youth, telomere length is about 7.75 kilobases, or kb, and in advanced age, it's about 5.75 kilobases. Now, the age-related decline for telomere length is potentially important because relatively longer telomeres are associated with a decreased risk for the incidence of Alzheimer's disease and Alzheimer's disease-related dementia, and that's what we can see here. On the y-axis, we've got the cumulative incident risk for AD, Alzheimer's disease, or AD-related dementia, plotted against time with an average follow-up time of 12 years after the initial assessment of telomere length. And then there were 6 different telomere lengths, and note that the actual amount in kilobases wasn't reported in this study, unfortunately, so we only have relative comparisons from short to long telomeres. So when compared with people who had relatively short telomeres, as telomere length increased, we can see significant decreases for AD and AD-related dementia incident risk, as shown here. As telomere length increased, we can see that risk significantly decreased. So with that in mind, what's my data? And more specifically, which factors may impact telomere length? And I mean that outside of the published studies in other people, what may impact it in my own N of 1 data? So first, in terms of what's my data, in 2022, I've measured telomere length 3 times. And note that these data are generated with True Diagnostic, and there'll be a discount link for those who are interested in measuring their own telomere length in the video's description. So over those first 3 tests, my average telomere length was 7.04 kilobases. And if you remember what telomere length looks like in youth, it's 7.75 kilobases. So based on my 2022 average, I have some work to do based on telomere length. So for the first 2 tests in 2023, there was some progress, 7.13 kilobases on the first 2 tests. And then for test number 6, which was in April of 2023, we can see that telomere length was 7.15 kilobases, such that the average of these 3 tests in 2023 is 7.14 kilobases. Now, when comparing these 2 groups of data, the 3 tests in 2022 versus the 3 tests in 2023, with a 2-sample t-test, the 2023 data is significantly longer or significantly better than 2022. Now, note that I'm not taking this data too seriously. It's only 6 tests. Each group only has three data points, so it's good progress, or it's going in the right direction. So hopefully I can continue this lengthening of telomere length, even by a little bit, and resisting the age-related decline. All right, so which factors may impact telomere length? And for me, I think the most important factor may be calorie intake. So over these 6 tests, we can see how telomere length correlates with calorie intake, with telomere length on the y-axis plotted against my average daily calorie intake on the x. And note that the average daily calorie intake is from the day of the previous test to the day before the most recent test. So that average daily calorie intake corresponds then to that blood test for telomere length. And I've done that 6 times, and I do that for every blood test in order to look at correlations for diet with blood biomarkers. So when looking at the correlation, we can see that it's inverse. In other words, when calorie intake has been relatively high, telomere length has been relatively low. And conversely, a relatively lower calorie intake is significantly correlated with a longer telomere length in my data, which then raises a question: what will happen if I can go lower for my average daily calorie intake? So what about diet? More specifically, how does calorie intake relate to diet? Which components, or do any components of diet, relate to telomere length? So first, let's take a look at foods significantly correlated with longer telomere length, and we can see that list here. And then let's go through what's actually included in this table. So first, the little r is the correlation coefficient. And we can see that each of them is positive, which means that a relatively higher intake of each of these foods is significantly correlated with a longer telomere length. And when I say significantly correlated, we can see that the p-value is less than 0.05 in each of these cases. Now, for those who are interested in adjusting for multiple comparisons, I did not do that because that will probably throw away some data which may actually be involved in mechanisms related to telomere length. And because I don't know which may be a true positive or a false positive, I don't want to throw away any data. All right, so then for each food, I have an average intake range over the 6 tests, and then my intake for the last test. Now, I don't know if any of these foods are causative in terms of impacting telomere length, so eating at the high end of my range for each of these foods may be beneficial in terms of potentially impacting telomere length. So let's see if that's been true, just using it as an example without going through everything on the list for olives. So olives, my intake range has been 0.3 to 2.1 grams per day over these 6 tests. So when considering the significant positive correlation for olives with telomere length, that suggests that eating at the high end of my range may be beneficial. And we can see that on the last test, or corresponding to the last test, olive intake was 2.1 grams. So I indeed was at the high end of my intake range for olives. And if you look at all of the foods, I'm generally following that trend, with the exception of mushrooms, which at 273 grams per day isn't 299, but it is higher than my lowest intake of 227. Now, what about foods that are significantly correlated with shorter telomere length? And that list is shown here. So again, just breaking it down, the R in this case, all of them are negative. So these are foods that a relatively higher intake is significantly correlated with a shorter telomere length. And we can see that in each case, the p-value is less than 0.05, so it's nominally statistically significant. And then again, we've got the intake range and the last test amount. So in contrast with the previous data, the low end of my range in terms of intake for these foods may be beneficial for telomere length. So let's see how well or not that I've been doing with that. So just using cacao beans as an example, we can see that my intake range was over these 6 tests was 5 to about 10 grams per day. So based on the significant inverse correlation, that would suggest that eating towards the lower end of my range may be beneficial for telomere length. And we can see that on my last test, it indeed was at the lower end of my range, 5.2 grams. So for most of these foods, I'm following the correlations, eating at the low end of my range for these significant inverse correlations with telomere length. Dates could be a little bit lower to get closer to the low end of the range, and similarly so can corn. But corn is a big, there's a big difference for corn for 87.5 versus 82 grams versus my highest intake, about 230 grams. So I'm pretty close to following that correlation too. Now, if diet does have an impact on telomere length, following as many correlations as possible would be expected to optimize telomere length. And that's what I'm doing for both the foods that are positively and negatively correlated. So will this approach yield further improvements for telomere length? Telomere length test number 7 is scheduled for tomorrow, so stay tuned for that data in a future video. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. And before you go, we've got a whole bunch of discount links and merch that you may be interested in, including discount links for at-home metabolomics, NAD quantification, green tea, epigenetic testing, oral microbiome composition, at-home blood testing with Cyfox Health, and note that their panel of biomarkers is almost exclusively different from the at-home metabolomics, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Dietary brand, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.